Hello, YouTubers. Nick. I'm swapping the two of you right now. But Nick, do you have the keys to the live tweet? Do you want to push out? Hey, we're getting started. We're going live.
Sure thing.
All right. And I put it in Slack. Here we go. And let me see where it is. All right, and then I will hit the intro and we'll go. Anything all good already?
Tweeting it out.
Hello, JS Party people. Welcome to another wonderful episode of your party on the web, JS Party. I'm K-Ball. I'm your host this week. I am joined, first off, by one of my most common co-panelists, the one, the only, Nick Nisi.
Hoi hoi. How's it going?
It's going well. And then we have today a special guest, Daniel Thompson from the Towery project. Daniel, welcome to the show.
Hey, thanks for having me. It's great to be here. I've been partying with JS forever, it seems like.
Absolutely. Well, let's start with you, Daniel. So can you tell us a little bit about that partying with JS forever? Give us your backstory. How did you get to where you are today, and what is it that you're working on?
Oh, way back in the day, I went to art school and started doing stuff with electronics and loved it and kind of became that person who would fix your Wi-Fi, right? And then, more complicated questions came like, can you make us an auto-playing, auto-looping server for art projects at my gallery? And can you build me a broken robot? And can you build a file server for us? And, we need an archive. And with the challenges of modern media, you never really got away from the web. And a lot of my personal artistic projects actually used web technology, like the camera on the computer and streaming from remote locations. And, it's always been pervasive. And I don't know, I think 5 or 6 years ago, I decided, well, let's just get serious about this. I mean, it's always easy to look up something on Stack Overflow, and there's a big difference between that and knowing why things are the way they are and how you can squeeze a little bit of performance out of your if-then loops and how the JavaScript engine even works. I love getting to the bottom of the technology and understanding it. And in the course of one of those projects, I realized that the ecosystem for hardware and the ecosystem for software just wasn't really serving the creative community. And around that time, I met the co-founder of Tauri, Lucas. And at the moment, I think back then we were struggling with getting apps on the App Store for Pure OS. And for various reasons, the stack that was being proposed wasn't appropriate. And Lucas and I went shopping around and we found web views. And we're like, how come nobody told us about web views before? Like he was React and I was Vue. And all of a sudden there's this way to make basically a PWA, but with superpowers. And that kind of led to this 4-year experience of building an open source project, creating a community, staying responsible, and I don't know. It's been great to see this group grow like a piece of software, like an iterative growth where no idea is just thrown out because we don't know how to do it. If we don't know how to do it, well, we're engineers. That's what we do. We figure these kind of things out, And I mean, today, Towery is a stable framework for building desktop apps for the major desktop platforms. So Mac and Windows and 35,000 variants of Linux. Um, and it does that by leveraging the system web view. So generally speaking, you don't have to download a full web browser to run it, but it does use web tech for the user interface. So your ECMAScript 2020 and your CSS3 and all of that good stuff is going to run in a Towery app. And instead of a monolithic system where it's all JavaScript all the way down, we decided to use Rust as the core language that basically harnesses the web view and provides system level API access. And we use a communication bridge to pass messages between the user interface and the core. And then, in Rust, you have multi-threading. You have basically the entire system at your disposal. And so, if you have to do something computationally expensive, you don't use a single thread of Rust that's also trying to keep up with your 60 frames per second of GUI slidey thingies, and you just offload it to where the power really is. And that's, in our case, the Rust binary.
That's fascinating. I have a lot of questions. I don't know if we want to dig into them now. I guess I'll just jump right in as coming on to this JavaScript party talking about Rust and promoting that. I guess one question I have is to get started with Towery, and I haven't yet. But how much Rust do I actually have to know?
You don't need to know any Rust. As a matter of fact, we
Nice.
provide all the system APIs, so you can just interface from your TypeScript and get the results back that you want. If you want to read out the folder contents, you can do that as long as you grant permission to it. And I think that ease of access is important. Yes, you will have to install the Rust C. You have to have a compiler. It's good to have a package manager. I think these days without a package manager, you're in the Stone Ages. And that package manager is called Cargo. And you're going to need a couple other system relevant things that are different for different platforms. But we have a pretty solid explanation for Mac, Windows, and Linux users to install the requirements. And then it's a npm create Towery app command away. And then you get asked which framework do you want, and then we scaffold it all out for you, and you're good to go. You have a Towery app instantly. And one of the neat things about the Rust ecosystem that I really wish the JavaScript ecosystem would take on is examples. So we have examples for almost all of the features in our Towery repo and the lower, deeper tech libraries where you can see how the features are actually used. And we even have a verification app that we build to smoke test to make sure that changes to the code don't break the apps. And I have to tell you, copy paste is the programmer's keyboard, Control C, Control V. And that's how I learned to program. I didn't have formal education as a software engineer, and I know Lucas is smiling yes, Daniel, we know, we can see in your code. But what you learn as an engineer is the challenges you face, you have to solve them, and that somebody else probably had the same problem, and then you can find that. And what we're trying to do with our examples, and what every Rust project does or should do, is provide examples for people to see how it's actually being used, and then please copy our homework. Right? That's how this open source thing all works.
Yeah, I think that feeds into, there's this common misconception that you should start from the top-down explanation and people will be able to immediately see all the implications. But mostly we learn better by a lot of examples and then working up to the general principles.
Mm-hmm.
I mean, if you've never worked in Rust before, let me just break it down for you. So generally speaking, you have libraries that you can import and you can call that functionality. And you have, it's kind of like an execution loop. So basically, once you enter that loop, it'll keep on looping until you get some reason to stop it. You end the program, or there's a failure. And I got to tell you, in Rust, you fail a lot. Like, it's something you get used to, but that's because we are compiling the language down into something like a binary. It's machine code, it's very small, it's not interpreted at runtime, right? So the Rust compiler is written by just some of the most amazing engineers I've ever had the pleasure of talking to. I wish I would be able to understand everything they say, but when you make a mistake, the compiler is like, hey, this is probably wrong. You don't mean to have a string here. It's a different type. It's a common example of one of the various problems you can run into in a very strictly typed programming language. It's in a sense more strict than TypeScript. It's very, 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 very strict. You have to get it right. And if you don't get it right, it's not going to build. And I think for a lot of us, for myself, I mean, I came out of the JavaScript community back when everybody called it JavaScript. No one knew what ECMA even meant. One of the things that we face is, well, sure, you've got an error. Okay, it doesn't matter. You just catch the error and maybe you throw. Nobody uses finally, but at least it's there. And you're designing for failure. And what I find in Rust is that you're designing for success. And that design for success and the strict attention to, we say memory management is complicated in Rust, but I think the attention to your design is something that is of immense value for every engineer. And you can take that learning back to your TypeScript side of the world and become a better engineer. And I really feel that the people who've started with Towery with zero Rust experience, 6 months later, they're answering questions about Rust to people on our Discord. So it is possible to learn, and it does make you a better engineer, and it's a lot of fun.
I'd be interested to explore a couple pieces of that. I mean, one thing that I know from my very limited experience with Rust is, unlike with TypeScript, it actually gives you useful error messages when there are problems in the compilation step.
Can't argue with that.
TypeScript can occasionally, but it's pretty rare, right? I think most of the time TypeScript does an error and you're like, shoot, what do I need to do to figure out this error? These types don't match. Why not? They should. Whereas Rust's compiler will say, oh, this thing isn't right. Maybe you meant to do this instead.
Check out error message E462. Yeah, E462. It's sometimes helpful. It's also daunting. And I think that one place where the Rust community can do a better job, and I'm looking at the compiler crew right now, is making it less scary. Like, Eli 5 it for me, please. Because what you have to understand, the development of the Rust programming language is evolved and been forced by extraordinarily intelligent people who've been following along in the whole conversation. And for beginners, sometimes it feels like somebody just brought you into a Discord chat that's been going on for 6 years, and you don't even know, what are you talking about here? And I think that it is something actively being worked on to make that helpful compiler message even more friendly. So it's on the track to getting better. I know it.
The other thing I was curious is you sort of mentioned, okay, playing around with Rust will make you a better JavaScript developer, better TypeScript developer. And I'm sensing as you continue talking about types and other things that your use of TypeScript specifically was not just because Nick Nisi's on the show, but because types are somehow important to the story here. Can you dig a little bit into what working in Rust will do for your TypeScript?
One of the things that we're revising internally is the fact that your experience using the Towery interface, and this is where it gets a little bit nerdy for Towery users, so I'll try to keep it on a higher level. But when you create a command that allows you to interface with the Rust, you're going to be doing that in TypeScript. And how do you know for a fact that the types are the same on both sides if you're only passing messages? Right? So there's a couple approaches that we're working on that will actually provide those types from Rust. So that as long as the Rust compiles, your TypeScript is going to be fine. And you're going to be able to talk with the same types across the boundaries. And for me, what that ultimately means is that, when we're talking about structured data, we know on both sides what we're talking about. In a sense, it's the best parts of convention and configuration, right? So you're able to configure it, but you have this convention that's going to keep it going from the source of truth. And I feel like the strongest types available in a Towery app are going to be coming from Rust. And in the user interface, you want to have access to those types. You don't want to be messing around like, yeah, you've got a user profile with ID, and that's an integer, and password, and that's a obfuscated encrypted string. And then Towery doesn't care how you pass your bytes around. Like, yeah, you have to serialize, you have to deserialize. That's the nature of the beast. But when you talk about developer experience, and I think that's what TypeScript really brought to our ecosystem, is think about your types, make sure that they fit, and find the truth and stick with it, right? And so what we're trying to do on the Rust side is provide those same sources of truth to the TypeScript side. And if you were to ask me, should I build an app in 2023 using Towery, would I choose TypeScript or JavaScript? I mean, what do you think I would say?
CoffeeScript.
TypeScript. Yeah, CoffeeScript.
So am I hearing you correctly that you're actually generating the TypeScript types from Rust, similar to how you might get, TypeScript types generated from a GraphQL?
There are ways to do this. There's a project from a group. I don't know if you've heard of Space Drive before. They're building an app to collate all of your remote drives. And they built an amazing project because they were facing this problem themselves. And we had a solution that we were working on internally, but these guys are so excited about Towery that they just joined our working group. They joined the open source working group, and right now we're discussing how to effectively place this type definition manufacturing system into the core, or is it going to be a plugin? Because I mean, really, in 2023, who starts a project without TypeScript? But I mean, there's nuances there to deal with, but it's really important to us that you have this unified development experience, because once you start like building a greenfield project with the Towery ecosystem, you're going to use a TypeScript front end, but you're also going to leverage the power of the Rust core. And if you need to switch your mental model from one to the other because you are not strictly managing your types across this boundary, I mean, in a sense, it's also why people love GraphQL, right? Like you have the same mental model everywhere, and that like reduces the cognitive load when you're switching between these contexts. And for bigger projects, between teams, right? So maybe you just have a front end team, and you have a back end team, you have a DB team, you have the ops team, you have the QA team, you have the management team, and all these teams need to talk the same thing. And from that meta perspective, I think that agreeing on what it is we're talking about has to be done in a strict way. Otherwise, you're doomed as an organization and as a project. Like that's architectural debt, organizational debt right there.
I think that's a good cut point for a first segment. Anybody need a bio break?
I'm good.
All right. So let's roll back in and talk about what makes Towery special to a user. We've spent a lot of time talking about some of the what is Towery, some of the fundamentals, some of the principles even that you're following there and thinking about it. But if I'm deciding on a toolkit to use because I want to build a desktop application. What are the things that Towery has focused on that make it unique, and what I should choose?
Well, you used an interesting word, and I'm going to start being strict about words because I think they're important. You said user. And my first reaction was, oh, the user of a Towery app is the person who downloads it and installs it on their computer. But then I realized that you meant the user of the framework, which is also a very valid user persona. However, I think for both of these personas, what I'm about to say is going to align very well. And that is, first and foremost, the size. So a classical Towery app these days weighs in at about 6 megabytes. If you're using something like Svelte, might be a little bit smaller, React, maybe about that. You can be careful about how you bundle in your images, and there's ways to get down to 3 megabytes. I think Jonas from the working group was able to make a 500 kilobyte Mac OS app bundle. So the size is relevant, and without going too far into the spoiler, I think it's actually where we are in the 2020s, right? Like the 2010s were all about, thank goodness it works. I built something that works. I don't care how I got here, but it works, right? And that whole free real estate mentality has led to engineering paradigms where on every data frame, you send an entire object across the wire instead of sending a diff, for example, when something changes, right? Like, I got it to work, so whatever, I don't care about the consequences. And I mean, we can be honest with ourselves. A hobby application that 1,000 people use doesn't have that much impact. But a VS Code that is used by tens and hundreds of millions of people around the world on a daily basis that weighs in at 600 megabytes, and every download, every update that they ship every 2 weeks is another 600 megabytes, that is a massive amount of traffic. And yes, if you're in a place where you have a good fiber uplink, you don't notice it, right? You just kind of suck it. And your hard drive just kind of is like, okay, I still have enough space. I don't have to delete those photos, or I'll keep those videos around. It's still just 600 megabytes, right? I was in Istanbul about 5 weeks ago, and I have 2 cell phones. I have a work cell phone, a mobile phone, and a personal one. One of them is a French mobile phone, and the other one is a Maltese mobile phone. And one of them wanted me to pay 10 cents per megabyte of transfer. Did I have any other Wi-Fi access? Not one I trusted. Could I update VS Code? That adds up, right? And I think this notion of, hey, who cares? It's just traffic is blatantly wrong. And I mean, I could go on for hours about how even reducing the package bundle size is a positive step in the right direction for protecting our environment. But I think the next most important part of Towery apps is the security features that we offer as a framework. Now, as you know, Rust is a language that is strict with its memory management, which provides a number of memory guarantees, but Rust isn't a panacea. I think that's something like people who are new to the Rust community ecosystem, listening right now for the first time, hearing about Rust, need to get through their heads. Just because Rust is better doesn't make it a silver bullet. You can still write bad, insecure code in any language that exists. Just because it compiles doesn't mean it's great yet. It's a good start, but it's not perfect. And we've done our best on multiple layers to provide security guarantees, in addition to, things like code signing, which everybody has to do for Mac and Windows apps. We force the developer to add a private key that then is used to sign the bundle so that the application knows when an update comes that it is actually a valid update. So, we don't just trust the ecosystem, and I think that's something that hopefully comes through here. Like, we don't even trust the device, right? So if you as a developer don't need access to the file system, then you just compile it out of the bundle, right? So we use this tree shaking feature that modern ECMAScript allows you to do when you're importing or requiring a subset of the exported functionality from a library. We do the same thing for Tauri core. So the idea of feature-based compilation becomes really exciting because you don't need all of the code for every single platform. And I think, when you have an environment that is interpreting what it gets fed, it has to be multi-purpose. It has to be able to do everything at any time because it never knows what it's going to get. Whereas in our context, if you just need file system access and you want to drop into a shell or run a command, then those are the features and functionality that gets baked into your app and nothing else, right? So we're removing surface area, which reduces gadget attacks. And
Can
I'll take a breath.
jump in really quick here? So when you talked about that and the tree shaking and cutting things out, my mind, being more of a web developer, immediately went to supply chain attacks, right? I'm including a package. I know that I don't want it to use the file system, so I'm going to say there's no file system in this. And if it tries to use a file system, I am, that's not my problem in a lot of ways. But can you, you're talking about something very different, and my headspace is not usually in thinking about devices, but I saw, you said this, I saw on the website, the fundamental here is this concept of the device should not be trusted, right? It's not like a browser where we can assume it has some things, it doesn't have some things. It's controlling it. We control our security. We keep certain things on the server. All of this is going to the user's device. So what does it, what does a malicious device impact on an application even mean? Eli 5, to me, the web developer who doesn't deal with devices.
You do deal with devices. They're just abstracted away from you. You're not allowed to touch them. Right?
Fair enough. Yeah.
Here's a shiny toy. You can look at it. What does that mean for us? Well, I'm sure you know what XSS is, right? The cross-site scripting attack. Basically, illicit JavaScript is being performed, and you never expected it. So it's unexpected behavior, kind of similar to, browser extensions, right? A browser extension is basically a kind of super-powered addition to your website that you never thought existed because you can't know about it. What does this mean to a device? Well, if you were able to compromise the front end with an XSS attack, and the browser, for whatever reason, already has file system permissions, you can read out the file system into a blob, read the file into a blob, and then request it in chunks to some attacking server, right? For Towery apps, there is no web view interface to the file system. You have to request it from the Rust side. So basically, to open a file, to read the binary or whatever representation of the file, you have to request that the Towery Rust side does that, and then it will return it to you. But if we do not ship the file system reading functionality with the app, that attack is just going to flat out fail.
I like that. But those pieces that you're tree shaking out, the way that I'm picturing this, and you can tell me that I'm completely wrong, is there's that code that's probably written in Rust, there's my code, and then there's this effectively a browser to run my code in. Wouldn't all of that pale in comparison to the size of the browser that you're shipping with it, or the web view piece of that?
We're using the system web view.
Oh.
So on Windows it's WebView 2, on Mac it's WK WebView, and on Linux it's WebKit GTK.
Oh, so it doesn't have to ship. I'm thinking in terms of having to ship a Chromium version. I know it's not Chromium, but okay, it's just using what's natively there.
Well, I mean, I'm going to be totally direct and honest with you. That does also bring challenges with it,
Sure.
right? So on Mac OS, basically, if you're not using stupid arcane hacks, you're stuck with the version of Safari WebKit that your version of the operating system runs. And the only official way to deal with that is to update your operating system. It's a trade-off. And I think the general win is that we felt you have a greater chance of updating keeping your operating system up to date for Mac than updating the 1,000 apps you're going to be running. And Windows actually does a pretty good job of keeping the WebView 2 up to date. So in that context, we are leveraging the platform ecosystem. And I mean, then there's the performance question. So you asked me earlier, like, what makes Towery special, sort of, and we talked about the size of the binaries, which is small. We talked about the security features that we've baked in, and I didn't go into detail on all of them. There's, maybe if you humor me, there's one more that's really amazing, and that is we built a system for communicating with the Rust backend that can be trusted using iframe. So it's on our site. I'll share the link with you in a minute. But basically, it's written in pure JavaScript, so there's no weirdness going on. You can audit it exactly, and it actually came out of the response to the audit that we had done for 1.0. So I guess that's the final security feature, is our approach to security, and that is we audit internally, but we also audit externally. So Towery had, I think for 1.0, over 50 findings from the external security team that we resolved, and one of them, the hardest one, the trickiest one, is how do you protect this message boundary between the web view and the Rust? And as a response to that, we developed a mechanism that passed the audit that does exactly that through a protected iframe.
So is that like using post message or something to do that communication through it, or? I'm thinking in my simple.
Well, the problem is the parent frame can never really know what its children are doing, and the children shouldn't have access to the parent.
I'm curious too. Are you signing something across it? Like you bundle some sort of key when you do the bundle, or some sort of encrypt decrypt type thing, or?
So I'm just going to read to you from Chip's post about it.
And we'll find that post and put it in the show notes.
Oh, we just revised the search on the site, so I can't find anything anymore. Can we circle back to this?
Yeah.
Oh, absolutely. What we'll do is we'll put the details in the show notes. So send us a link after the show. We'll put it there. Anyone who's curious, I know I'll be going and reading through because I'm curious. I could dig into exactly how you do it.
It is using a post message, and the key for the encryption of the message is injected from Rust. But like the details are quite long.
Cool. All right. So you were about to tell us about performance.
Right, and this is actually one of those weird situations where I think different platforms have different interpretations of what performance means. So the Windows platform tends to be the one that people analyze the most and think that the memory overhead is the big issue, right? And so depending on how you analyze it, some people say that Towery only has a little bit of memory, a little bit less memory needs than, for example, Electron. But the interesting part about WebView 2 on Windows is that the shared nature of it reduces the overall memory load. Whereas if you're running 10, I'll just name the 10 Electron-based apps, you're not sharing any memory because they're all isolates. And what that means is when looked at from the isolated perspective of one app compared to one other app, you're going to find comparisons that are similar. As soon as you have 10 of each or multiples of each framework running at the same time, you'll see that the total memory load is lower.
Are you saying that if Slack was built on Towery instead of Electron, running all of the 10 different workspaces that I'm in would not use 10 times as much memory the way it seems to now?
I'm going to say WebView 2 because WebView 2 is the salient technology here. Towery is hooking into WebView 2, so any other system that's using the WebView 2 evergreen model for the distribution is going to have those perf gains. This is a super hot topic on Twitter, and I mean, I guess the question that people need to ask themselves when they ask about performance and how is one performing better than the other, and it's all just a web view and it's JavaScript all the way down, comes back to the architectural design that people choose, right? Like if your app is running in a single threaded environment, maybe you have a web worker. So you've got 2 threads. And one of those threads is consistently repainting all the time in order to catch that request animation frame. There's no way you're going to be doing heavy computation. There's no way you're going to be streaming millions of data points at 60 hertz. It just is not feasible. And when you start looking at high performance applications that need to have that data throughput, maybe they don't need to display everything, but they have to pass that data through in order for the user interface to decide what it shows. I'm not sure other single-threaded runtimes are going to be up to that challenge, right? And so with a clever architecture of separating the concerns between the user interface and the back-end core allows you to have as many threads as you need ultimately. You know, like you could be rendering a stream in the back end and showing the frames in the front end, and you can also ask for a notification to pop up, and none of it is really blocking because the entire message boundary is async. So you really have this world where a message passing is golden, inter-process communication is the way stuff works, but it's messages. And I think that when it comes to performance, and that's something that we're really excited about and working on improving, is that you have to define, you have to be strict about what you mean, right? So that comes back to that whole rabbit hole of what are we even really talking about here when we call an app performant? Like, are we talking about having a list of 1 million elements that you want to be able to scroll through like butter? I'm not even sure that other like native frameworks, I mean, maybe Flutter can with some trickery, but I believe it's really only rendering the things that need to be on the screen when they are on the screen, which is the right way to do stuff. So just because your website isn't rendering in 60 or 120 frames per second, it doesn't mean that it can't. It just means that things need to be re-architected. And I believe that there are situations in specifically molecular analysis, for example, where you need to have that performance and you just cannot get it from a browser.
This reminds me of a conversation that's been sort of popping up in numerous JS Party episodes recently, which is, and I think it ties back to something you were saying earlier of like the 2010s, there was the, oh my gosh, can we get it to work? And, you know, we have things like Electron doing some really interesting stuff, and you know, other things that were enabling possibilities that didn't exist. However, we got in this world, the JavaScript ecosystem definitely got in this world where our defaults make it very hard to build something that is small and performant. Our defaults make it such that the architectures that we develop are large and bloated and do all of these other things. This is something I think, that in the JS framework world, Astro's looking straight at this. Svelte is looking straight at this. Even Quick is looking straight at this. Even like Preact and what is it, Vue Mini or whatever they are, like they're trying to tackle this thing. But there's an architectural piece to that. And if I'm hearing you correctly, some of the choices that Towery pushes you towards are to something that is going to be smaller and more performant by default. Is that correct?
I would absolutely agree with you, and I think what we're seeing now is close to a paradigm change. I mean, last summer when we released the Tauri 1.0, it was the week where both Internet Explorer and Atom Shell's deprecation was announced. And I think that technology has the ability to stay relevant as long as the people using it are not afraid to continue developing it. And, if you look back to all of the IE11 browser hacks that had to be applied to just even get anything done, and it was like a workaround on top of middleware. And I'm not saying that Internet Explorer was bad. It's just a piece of technology that served its purpose. And I hope that what Towery is able to do is also to serve that purpose of bringing engineers back that absolute power, that performance that you can have, the GUI that is slick and smooth, and the state mechanisms that you love. And JavaScript is great where JavaScript is great, but you don't have to use it just because that's all you have at disposal. We're bringing you new tools that you can use. And I think that the paradigm of web development, and I'm going way out on a limb here, but I think that Towery brings us closer to this thin client idea of the mainframe age, where you had this heavy duty machine, and then you had a telnet client that was basically just this little thin thing to talk to the big heavy machinery in the back. And I sort of see Towery apps as that similar window to the power that your device actually has. And I don't think that device manufacturers are intentionally throttling us so that we can't have the full performance of our devices. But personally, I enjoy having all of the cores of my M1 Mac at my disposal, because sometimes I do need them.
That seems like another good cut. I reorged a couple of things into segment 3. But Nick, I also noticed you have been pretty quiet. Are there topics that you want to dig into?
A couple, yeah.
Okay. Do you want to bring us in for segment 3?
Sure. So in like coming at this from, getting started in a web dev perspective, you did mention like selecting the right framework for it and getting started with that. I'm curious, is there something special about like the approved frameworks with it that like you're building on top of, or is that just like a helper and you could really use anything out there, or does it only work with a certain select set of frameworks?
Unfortunately, it works with every framework.
I like that answer.
So unfortunately, I love that. So if you want to use jQuery and build your Towery app, you can.
That's what I was asking, really.
Right. I know a lot of people are still using jQuery, and I don't recommend it. But if you had to for some weird brownfield compatibility stuff, you could. And that is tricky for us as platform engineers. How do we support all of them? The easiest way to get started is, from a JavaScript perspective, is just to run create Towery app, npm or pnpm or yarn or whatever. And you'll be asked a bunch of questions like, do you want to use TypeScript? Yes or yes. I'm kidding. Yes or JavaScript. Do you want to use one of the big five? I think right now we're at Svelte and Solid and React and Vue and Vanilla. I think those are the ones that we're officially going to be supporting. Of course, the community has provided a lot of other ones. It gets hard to maintain, especially because of the velocity of frameworks, but I think it's hard to bless a framework. I can tell you what I like about frameworks. Like if I was to choose a framework, I would choose a framework that bundles tiny. That bundles straight to HTML and JavaScript and CSS. So I'm sorry, VDOM, I never understood you. We had a long relationship, but I never, no. I mean, it can be, doesn't have to be. Freezing the prototype from a security perspective, from a logical perspective. I mean, a lot of Heisenbugs that I've seen in my time have come from people clobbering the prototype, and you didn't know it because they didn't tell you. And the prototype is just boom, it's different now. And we offer the ability to freeze the prototype. So Vue.js, as you know, freezes after it builds. So basically, we can't freeze before. So Vue modifies the prototype because it has to. And while I understand their decision, there's also that point in time before Vue.js exists that is still dangerous when you're not in a browser context. Like Towery apps can eval anything from the Rust side. So Rust really has that kind of superpower to do anything it wants at any time.
When you say freezing the prototype, can you clarify what you mean? Is it like, I'm thinking like object.prototype in my head, but
that's what we're talking about. Like,
okay.
So one example of a prototype being clobbered might be used in console rewrites, for example. And I think it's less about the fun parts. It's more about the expected parts and the things you don't want to happen, right? So if you're able to attach a new parameter to a const that is part of the language framework, it's scary. And there's like, if you don't freeze the prototype, you're doing something wrong.
Yeah.
Like if you're not freezing your objects after you make them, because you know they're never going to change, you're just forgetting the important stuff, in my opinion. And so modern frameworks that do allow us to freeze the prototype are Svelte and Solid.js, for example. They both let us do that, and they both provide very small bundles at the end of the day. And I think depending on where you come from, if you're coming from the ECMAScript corner of the universe, if you've got a React-y kind of background, then Solid makes sense. And if you've got a Vue kind of background, then Svelte makes sense. And if you're absolutely new, like you've never done any JavaScript before, learn TypeScript first. and then decide what speaks to you. Because JSX, TSX, whatever it is these days, is it's a different flavor. I think it also has a lot to do with who you get to work with, like who your friends are, who you want to learn from. So, yeah.
Speaking of who you want to work with and who your friends are, if somebody wants to work with you on this open source project, they want to get involved, but maybe they're a beginner, they may have never done Rust, what have you. How can a beginner start getting involved with Towery, the open source project?
Well, I have always been of this very, very strong opinion that any contribution is a viable contribution. If you want recognition, make a pull request. Like there's your name on it. If you want to help, join the discussion on Twitter and ask hard questions, or come to our Discord and get informed, because even asking questions sometimes leads people who are maintainers of the framework to internalize that question and really think about what they're building. And, you know, the easy win for people to get involved is supporting the documentation effort. Like, with a massive project of this scale that has so many entry points, sometimes we make a grammatical mistake. I probably made a grammatical mistake just saying that right now. I don't. I think that contributing to open source doesn't have to be just about the code. It can be about being involved. And what you'll find if you start contributing to documentation, especially around the API, you have to learn the code. And that means you go into the code, and by reading the code, you become familiar with the code and the standards and the way it's been written, and that will make you a better engineer. Not overnight. This is a long, long, long process, but it will. And I think ultimately, if you get a taste of Towery and you like it, I have to tell you, we have a very open working group. It's very flat. All you have to do is have made a couple contributions and say, I want to be part of the working group. And we'll bring you into the working group, and you can then hang out in the smaller channels that we use for, you know, discussing strategy and figuring out how to do releases. And we talk about marketing and conferences, and you know, that itself is involvement. And I guess inspiring us, like that's the thing that really keeps me going, is going on Twitter or GitHub when someone goes to our awesome Towery repo and makes a PR, and seeing the crazy things that everyone is building is an inspiration and a kind of support that is more important than a financial support, because open source engineers love seeing the stuff that you're doing with the work that they're doing, and that drives them to make it better and, you know, listen to your requests. I think that, that's...
Yeah. I love that trend of awesome dash whatever technology and just like accumulating a list of things like that. So it's really awesome to hear that that's there for Towery. That said, can you think of any unique or interesting use cases of Towery off the top of your head?
Off the top of my head, one of the projects that we're using is Padlock. So Padlock is a password manager. It has teams, and they're not paying me to say this. It's just a product that we love, that's built on Towery, that's open source. Really, really kind of cool. And there was one Galata.app. Like, it's super nerdy, and I find a lot of projects these days are scratching the dev's itch. So if you're into Kubernetes and you want to track stuff, check out galata.app. It's a neat little project with a cute interface, and it frickin' works. And there was one more that I found today. Recut is what it's called. I think it's getrecut.com. And it's a really simple app. Basically, it takes all of your video footage and cuts out the parts that are silent. Because if nobody's talking, nothing's happening, who the heck cares? And he uses Towery for the user interface, and it's not open source. Again, not being paid by anybody to do this. It's just fun to see that tools are being built, because that's ultimately where Towery comes from, this drive to make a better tool, to make it useful for people, and to put the power back in our hands.
Yeah, this is really cool. I'm looking at the recut, and I mean, it's just a cool, unique example of something that's not just like forms over data, and it's doing a lot, which is really cool.
One other really interesting one is at our Discord, we have a channel that's open to everybody. It's called Showcase. And in the Showcase, you can talk about the apps that you've made. And, wow, there's a couple new ones from wow, all right, cool. There's one called Curses, and Curses is really cool. They've been around with us for like 2 years. And what Curses is doing is making speech to text and text to speech for OBS and VR chat. Which, like, if you're into streaming and or you have a speech impediment of some kind, it's an utterly useful tool. I don't know if I have a link for it. Yeah, I can paste that in our chat here. Curses.
Awesome. Yeah, this is super cool. Well, so for folks who are interested looking at Towery, what's coming down the pike? What you talked some about Towery 1.0. What's going to be in 2.0, or what are you excited about that's coming in Towery soon?
Well, 1.0 brought desktop and basically the validation that we deserve to exist, right? 2.0 is bringing mobile. So for Android, iOS, and I believe we're also going to support F-Droid, you'll be able to use the same API interface that you're used to for Towery desktop and build and ship those apps for mobile. There's a refactor of the API that came about because of the permission system for mobile. That means in order to keep parity, we have to revise. But along those lines, we're also making our plugin system available not only to the web view, but also to the Rust side of things. What else am I particularly excited about? Well, I am really excited about our foundation. It's going to have new members joining this summer. In July, we'll have the new votes, and we're hoping to bring in more people from the community. And I heard there's a company somewhere out there that is working toward providing Towery services. So I expect them to come out of hiding sometime this summer so that you'll get your one-click deploy for Towery apps. And yeah, I mean, it's great to see the ecosystem growing around it.
Awesome. Well, I think we've covered a lot of ground, but I'm definitely excited to go and check out Towery a little bit more. A lot of good stuff in here. Amazing. Daniel, anything else you want to leave our listeners with before we wrap up?
Just the plea to become better and never give up and keep learning. Like that's what I've learned from Rust. Like at a certain point, you're just tired of like JavaScript and you want to learn something new. Pick Rust. It's definitely going to pay off because I know a lot of people are hiring right now and they don't know where to get Rust engineers. So job security is absolutely there. And a pay raise, I think.
Does seem to be a trend too.
Yeah, definitely. Their Rust is definitely a growth area. Awesome. Well, with that, I think that wraps up our Towery on JS Party episode. Thank you, Nick. Thank you, Daniel. And Thanks. This is K-Ball signing out. We'll see you next week. Same time, same place on the party.
Ciao.